All right, let's look at this question. Right, so this question, they gave you two equations in three variables. Notice it's in three variables, x, y, and z. So equations, we label them. Equation number 1, equation number 2. Okay, then they ask you to find the value of a such that the system has infinite solutions. Alright, so what is this value of a so that this system has infinite solutions? Right, so they give you two equations. Bear in mind they have three variables, means they are planes, right? Three variables means they are planes, right? Flashback, two variables, they are lines, right? For example, two variables can be x plus y, let's say, equals to 1. That graph would look something a bit like this: x-axis, y-axis, right? X and y-axis. But three variables, they are planes. Now, what are planes? Planes are in three-dimensional. So two variables are 2D, three variables are 3D. So they will have both y and x-axis, but they will have a z-axis. They are 3D, and they exist as a plane. These equations represents plane. Plane is a flat surface in a three-dimensional space. Right, let's look at this example here. You can plot this yourself in Desmos. You just search up Desmos 3D. You can see, okay, this is a plane. Example, x plus y plus z equals to 3. This is a plane. You can see that it's a flat surface in a three-dimensional space. Right? And it goes on infinitely. Just like a line, it extends infinitely. Alright, so now we have idea of what is a plane. Let's go back to here. Okay. So, get it. Three variables is a plane. Alright. So, now they're asking for these two equations such that they have infinite solutions. What's the value of a such that these two have infinite solutions? Let's look at lines first so that we can draw a comparison. Right, so lines, what are the type of solution for lines? Let's not look at planes first. So type of solution for lines, type of solution for lines. So there can be no solutions when two lines are parallel, remember? And there can be one solution where two lines intersect each other. One solution. And there also can be infinite solutions if two lines are identical. Let's say this is one line and then there's another line equation, but they are the same line. That's represented by the red line. They're identical, so they intersect each other at infinite many points because they are the overlap. So they have infinite solutions. Infinite, right? So there are three cases. Okay, right? So that is lines. Just a bit of flashback on lines. Now let's look at planes. Okay, planes will be special because you are given only two planes, right? This situation is two planes. So for two planes, there will be three scenarios. Keep in mind, this is two planes, not three. If three planes, there will be more scenarios. But two planes, there will be only three scenarios. Let's look at the scenarios. First, identical. So the planes will overlap each other. And they are the same plane. They overlap each other. So they intersect as infinite many points. So this has infinite solutions, same as the line. Right? I just draw like this for illustration purposes. Next, they have two planes that intersect each other. Okay, this one plane, and you have another plane that intersects it, like this, intersect. So they will intersect at a line. And as you know, a line goes on infinitely. So this one will have infinite solutions too. Infinite solutions. Right, so what do I mean by this? Let's look back at decimals again. Okay, let's say consider these two planes. The first red plane and the second blue plane. They intersect each other. Notice how in between them they intersect in a line. Notice they intersect in a line. See this line? It goes on infinitely. Infinitely the line it goes on. So they have infinite solutions. Even though they are not the same or overlapping, but they intersect at the line. This line has infinite solutions. Right. And last is parallel. When two planes are parallel, it means these two planes does not intersect each other. Right. So these two planes will not have solution, no solutions, because they do not intersect each other. Same as the lines. Right. So these are two planes. If we are talking about three planes, there are more scenarios. But for now, we are just talking about two planes. Right. So these are the three possible solutions and the three possible scenarios. Alright, so they say find the value of A such that the system has infinite solutions. So got two scenarios where there is infinite solutions. These two scenarios. And there's one scenario where there's no solutions. Alright, now there isn't really a way to find whether a plane is intersecting at a line compared to whether it's parallel or what. So there's this method where you can use is we solve for parallel planes because it's easy to find for parallel planes rather than we find whether it's intersecting at a line or not. Right. So if we can find, okay, let's say we find the value of parallel planes. Just an example, when A is equals to 5, the planes are parallel. Right. So if I say that find the value of A such a system has infinite solutions, A cannot be 5. Because when A is 5, it is parallel. Then that means there has no solutions. But I want infinite solutions. So that means A cannot be 5. If A is not 5, then A can be any number. Any number. Right? A can be any number. So we usually represent it using this symbol. A is an element of real number. Real number means can be negative, positive, fraction, irrational numbers, long decimals, negative 1, 2, 3, 4, 1.2, 1.3, 1.4, alright, 0.001, any number. Okay, so that's the basis, right? So how do we find this value of A? That it cannot be equals to. When it's equals to this value, it will be parallel and they will not intersect at all. Means no solutions, means there won't be infinite solutions. Right? Let's see. When planes are parallel, the coefficient of the variables should be the same or should be different by a factor, right? So these two should be different by a factor, these two should be different by a factor, and these two should be different by a factor. It doesn't matter the behind. The equals part doesn't matter. We are only interested in the coefficients of x, y, and z. Okay? Alright, so since that they should be different by a factor, let's observe. Notice how equation number 1, if I times it by negative 2, it will turn into equation number 2. Right? Okay, let's see. Equation number 1 times negative 2. Okay, 2 times negative 2, negative 4x. Negative 3 over 2 times negative 2 plus with 3y. 5 over 2 times negative 2 minus 5z. 1 over 2 times negative 2 minus 1. Right. And then let's copy down equation number 2. Plus 3y plus, plus a squared minus 14z equals to a minus 4. Notice how they match up, and that must mean this negative 5 should be equals to a squared minus 14. Only it will be parallel, right? Okay, so that means we can equate negative 5 equals to a squared minus 14. Again, we don't care about this part. We only care about the coefficients, right? Okay, so coefficients. Let's see. Let's solve for a now. So a squared will be equals to negative 5 plus 14. A squared equals to 9. A equals to plus minus square root of 9. Don't forget your plus minus for square root. So does a will be equals to 3 or a equals to negative 3? Right, so how do we know which is which? Is it 3 or negative 3? Now we can test this. So here's the thing. Why are there two answers? Because when the coefficients are identical, when the coefficient matched up, there are two possibilities. It's either it can be identical plane or parallel plane. Remember this. When coefficients are the same, it can either be identical or parallel planes. So how do we tell them apart? So it's now where we use this back part that I've been telling you guys to ignore all this word. If this back part is the same, identical means is identical, right? It's in the name, right? If they are the same means they are identical planes. But if they are different number, let's say this negative 1, let's say maybe this will be 5 or something, then they are parallel planes. They are different number. So they are not identical. How do we check? We can check by plugging back in the answer we got inside a minus 4, right? So when a equals to 3, a minus 4 will be 3 minus 4 equals to negative 1, right? Negative 1. So when a equals to 3, you know that these two planes are identical. So this is not the a value I'm looking for. So no, not this. Remember, we are looking for the a value for is parallel, right? And then now you test when a equals to negative 3, it will be negative 3 minus 4. It will be negative 7. Negative 1 does not equal to negative 7. So yes, when a equals to negative 3, they are parallel, right? Okay, so that's it. Now, how do we state our answer? A can be any value whatsoever. So a can be an element of the real number. But a cannot be equals to negative 3. It can be any value whatsoever, but it cannot be negative 3. Any value of a will result in infinite solutions, as long as it is not negative 3. So this is the answer for this question. What's the value of a? A can be any value of real number. It can be 1, 2, 3, negative 1, negative 0.1, can be 3.1, 3.2, 3.3, 3.001, anything. Except for negative 3. It cannot be negative 3. If it's negative 3, it will be parallel planes, which we don't have any solutions. Right. Okay. Alright, so here is a simulation to prove that a can be any real values. Okay, so I have plotted the first equation here, 2x minus 3 over 2y plus 5 over 2z equals to 1/2, right? So, okay, this is that plane, and I have also plotted the second equation here, okay, in terms of a. I have a slider for a here, right? Okay, let's see. So, this is the first equation. See the second equation. Right, here's the second one. then as you can see, that's for now a is negative 1.7. So as you can see, they intersect in a line. You can see they intersect in a line in between them, right? So that line goes on infinitely, so they have infinite solutions. Let's see, let me move. See, any value, they will intersect in a line and they will have infinite solutions. Okay, let's say -3, because we said, right, when it goes to -3, it will be parallel, therefore they won't have solutions, definitely won't have infinite solutions. Okay, now I set A as -3. Can you see that they are parallel? They are not intersecting at all. You can see the space between them not intersecting at all. They are parallel, right? What about identical planes? Just now we say that when A equals to 3, they're identical. Let's see. Yep, they're identical. How two of the planes overlap each other? Right, let me off this purple. Right, so this is the green plane, the first equation, and the second plane. Can you see that how are they overlapping each other? Yeah, that's what we mean by identical, overlapping each other, right? And as you can see, no matter what values of A, any value whatsoever, they will always intersect in a line. And this line goes on infinitely. Alright, so you can go figure this out for yourself. It's just like Desmos 3D. So, yep, that's all.